Okay, so what we're going to do in this test is we're going to test the moisture content of a sample of sand. So you can see here what I've done is I've gone out to my stockpile on site. I've taken a sample of sand in my dish. But what I want to do is just take a small amount of that. So what I have is a petri dish, which is just one of these small glass trays. I have weighing scales, I have a microwave, I have a little spatula for taking out my sample, and I have an oven glove as well for handling the petri dish when it gets hot. So what I'm going to do is I'm just going to take a small bit of the sample of sand. So what we're doing is testing the amount of moisture that is in this sand. So what I want to do first actually is to tare my scales with the petri dish on it. So before you add your sample, put your dish on the scales. We hit tare. So what that does is just sets the scale back to 0. So then anything I add to the dish is going to be my sample. So I just take out some of my sample. I won't put in too much because we'll be drying it all day and the video will be very long. So I'm just going to take out a small bit of sample. Just to highlight, if we were doing this correctly, the minimum test sample for this would be 500 grams. Okay, so my test sample today is 9.5 grams. Okay, so my M1 is 9.5 grams. So record that as M1. What we do now is we place the dish in the microwave. So we're using the microwave oven method. You can also use a conventional oven. Place it in the microwave for 1 minute. So after 1 minute we're going to record the weight. So the weight will have changed because the moisture content has dropped because we're adding heat. How do I know when all the moisture is removed? Well, I should get 2 readings in a row that are the same. So for example, maybe if the next one it drops to 8 grams, if I get 8 grams in twice in a row, I know there's no moisture left in my sample. So we just have to wait for the microwave to go through its minute. So this test is important to know the moisture content of your sand because first of all, you may need to adjust your mix. So if your sand has a high water content, well then you're going to have to adjust your concrete mix to allow for that water content. Also, if you're buying sand, well, you need to get value for money. So if our sand, say, has a 20% moisture content, well then 20% of that load of sand is made up of water. So you're not getting value for money, and also transport costs is another thing to consider as well. So it's been in for a minute. I'll put on my oven glove because the petri dish is going to be hot. We take the sample and we weigh it, and it's gone down to 9.3 grams. So record that sample at 1 minute, 9.3 grams. Put it back into the microwave for another minute. So then we'll record the weight at 2 minutes. So the other thing to highlight as well is that the microwave should be on full power, okay? So not defrost or anything like that. Make sure it's just on the highest possible setting as well. Okay, so take the sample out again and we weigh it, and it's now 9 grams. So after 2 minutes the weight has reduced to 9 grams. So it's still reducing, so we need to put it in for another minute. So back in for another minute. If at this stage the weight remains at 9 grams, well, we know the sample is dry, all the moisture has been removed because the weight has stayed the same for 2 consecutive readings. So you'll see in your lab books, and I'll put up a visualizer example as well, our starting mass or our wet material is known as M1, our finishing mass or our dry material at the end is known as M2, and we use a formula then to calculate our moisture content, which is M1 minus M2 divided by M2 multiplied by 100 over 1, and we get a moisture content percentage for our sand. Another 20 seconds to go on this one. So again, the dish, the petri dish is getting hotter and hotter, so just make sure at all times you have your oven glove or your heat resistant glove to take the sample out. Okay, so we take out our sample and we weigh it, and that is 9 grams again, okay? So our sample has stayed the same.